Section 6 in Chapter 5 we're going to split into several days. So this is day 1, entitled Slope-Intercept Form. Notice we are skipping Section 5.5. We'll hit on that topic a little bit later. So some vocabulary terms, few of these are review, but the first one is a linear equation, and it's an equation whose graph is a line. And an example of a linear equation is y equals 2x plus 5. Remember, we've worked a lot with graphing linear equations. We've looked at slope, we've looked at intercepts, and we've also looked at equations themselves and tried to determine whether or not they're linear. The y-intercept, which will be important here in slope-intercept form, is where the line crosses the y-axis. And slope-intercept form looks like this. Y equals mx plus b, where m is the slope. Remember, it's rise over run. And the b is the actual y-intercept. So first what I want to do is look at a handful of equations that are in slope-intercept form, and I want to identify the slope and the y-intercept of each equation. So for equation 1, y equals 4x plus 7. Remember, slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So in number 1, the slope, or m, is 4, and the y-intercept is 7. How about equation 2? The slope, again, it's always the number that's right in front of x, is 1/4, and the y-intercept here is a -5. Please notice the sign there is subtraction. That means that that 5 is negative, so this line would cross the y-axis at -5. Here are a couple, try these on your own. What's the slope and what's the y-intercept? Hopefully on number 3 you're saying the slope is a -2/3. Again, we want to take the sign with it, and it's the number in front of the x, and the y-intercept is a -1. Number 4 is a little trickier, but you have to recognize there is a number in front of that x, so our slope is a -1. Our y-intercept is 10. The last two examples are kind of special cases, but notice that if we write slope-intercept form, y equals mx plus b, number 5 actually doesn't have a b. It's got the mx portion, but it doesn't have the b. So you kind of have to ask yourself, what number is back there? Well, there's nothing back there. So how do we say nothing in a number? That's 0. So here on number 5, the slope is 5/7, and the y-intercept is 0. Number 6 is similar, but it's flipped a little bit. Now we don't have the x term. Notice there's no x in this equation, y equals -9. We could rewrite it if we wanted to. If there is no x term, it's like saying 0x. But we do have a y-intercept, and that's going to be the -9. But the slope here, when there is no x term listed, is 0. And our y-intercept is -9. So notice the difference. The y-intercept is 0 when we've got the x term but nothing else behind it. And the slope is 0 when we don't have the x term, we just have a number, our y-intercept. So now that we've had some introduction to the slope-intercept form and we've been able to identify the different parts of it, let's look at some examples where we want to rewrite the equation into slope-intercept form. We want to state the slope, the y-intercept, and then graph. So in order to rewrite an equation into slope-intercept form, the important thing you want to remember is we want the y by itself. And actually on this one, I want to make this a y. This should be a y. So on number 7, we have -3x plus y equals 5. So we want to get the y by itself. We want to move the x term to the other side. So we do that here by adding 3x to both sides. When we do, we're left with y equals, can't add these together because they're not like terms. And notice in slope-intercept form, the x term is written first. So we want to say 3x plus 5. So now we have it written in a slope-intercept form. Our slope is 3, and our y-intercept is 5. And now we want to graph. And these are actually really simple to graph. First, we want to start at the y-intercept. So we're starting in the back part of this equation at positive 5, and we're going to graph a point. Remember what the y-intercept means. That's where the line, the graph itself, crosses the y-axis. So we know our line is going through that point. The question is, how do we get the rest of the points, or how do we draw the rest of the line? In order to do so, we're going to use the slope, and we're going to write the slope as a fraction because we use the term rise over run. First, we notice our slope is positive, so we want to make sure we are going in the positive direction, but it's 3 over 1. So from this ordered pair, from this point that I plotted my y-intercept, I'm going to go up 3 and over 1. You can continue that pattern. Notice we kind of run out of graph this way. We can also go in the other direction. But notice you kind of have to go a different way. If I went up 3 and over 1, now I need to go down 3 and this way 1 in order for my line to stay a line. And I'm going to continue this all the way through the graph. My rule is going to be this. When we are drawing these lines, you need at least 5 points. We'll start with 5, and then once we get in a better habit of graphing, we may shorten that down to 3. Notice I have 1, 2, 3, 4, 5, 6, 7. I've got 8 points on my graph. So we go to the y-intercept first and plot the y-intercept. Then we use our slope to find all the other points. Notice this line does have positive slope. You will have to remember how that changes when a line has negative slope. Number 8, we want to rewrite. We want to state slope and y-intercept, and we want to graph. So we're going to subtract 2x from both sides. That's going to give me y equals negative 2x minus 3. I always want to write the x term first. So my slope is a negative 2, or negative 2 over 1 to help us write it as a fraction so we can do rise over run. And my y-intercept is negative 3. That's where we start. So I'm going to go down to negative 3. And now I'm going to use my slope from that point to graph my line. It is negative. So you can do a couple of different things. You can still rise 2, but you need to make sure that you're going to the left instead of the right. So I'm rising 2 and I'm running 1. Notice this line is going to have negative slope. Excuse me. If I want to go in the opposite direction, I'm going to need to fall 2 but still go to the right so that I can continue the same pattern of my line. I'm going to connect the dots. Notice I'm drawing arrows on the ends of my lines because they are lines. And we have it graphed. This one's a little different. It's going to be an extra step here in order to solve it and put it in slope-intercept form. But first I want to move the x term to the other side. So we're going to subtract 4x from both sides. But notice here I have a negative y, or subtracting y, so I need to bring that negative down with it. And I have negative 4x minus 3. This is like having a coefficient in front of the y of a negative 1. So I need to go through and divide everything by negative 1 because I have to get rid of that fraction, or that negative symbol. So we have y equals. Well, dividing by a negative, all that does is change all your signs. So instead of a negative 4x, we're going to have positive 4x. Instead of minus 3, we're now going to have plus 3. So please make sure you understand how and why that's done. Now we have a slope of 4, or 4 over 1, and we have a y-intercept of positive 3. So we're going to start the graph at 3. We want to go up 4 and over 1. And I've run out of graph this way, so now I'm going to go the other direction, down 4 and to the left. I don't pay a whole lot of attention to do I go up and left, or down and left, or up and right and down and right based on positive and negative, because I understand which direction a positive sloped line should go. So I know if I'm going up, I want my line in this direction. If I'm going down, I need to go over to the left because I need my line to continue that pattern. And I urge you to do the same thing. Try to understand which way is positive slope, which way is negative slope, so you don't have to focus so much on the ups and the downs and the lefts and the rights. See if you can solve this one on your own. Try to rewrite this in slope-intercept form, so pause the video. We're going to add 4x to both sides. We're going to bring down a negative 2y, and it's going to equal 4x plus 8. Now we need to divide everything by negative 2 to get rid of that coefficient on the y. We're left with negative 2x, a positive 4 divided by a negative 2, minus 4. So our slope is negative 2, or negative 2 over 1, and our y-intercept is a negative 4. Remember, when you graph, you always start at the y-intercept, then you use your slope to find the next series of points. I'm going up 2 over 1, up 2 over 1. It's rise over run. I can go down 2 and to the right to continue my line this way. I like to make my line all the way across the graph. Notice again arrows on both ends. So one final example here, rewrite in slope-intercept form. We want to get y by itself. So first we're going to add 3x to both sides. That's going to give us 2y equals 3x plus 6. We want to divide everything by 2. This one's a little different because what you're going to notice right away is that 3 is not divisible by 2, but remember with slope, we actually want to leave it in a fraction. We don't want to write 1.5 or 1.5. We want to leave it as 3 over 2x. And then we have plus 3. We divide 6 by 2. We do this because, remember, we list slope as rise over run, so it's a lot easier to understand rise 3, run 2. Our y-intercept then is a positive 3. So we're going to start our graph at positive 3. We do have positive slope, so when I rise 3, I'm going to run 2 to the right. If I go down 3, then I'm going 2 to the left. Oops, that one's off a little. 1, 2, 3, 1, 2. And here's my line. Again, when you're graphing, you need to make sure you have at least 5 points on the line, including the y-intercept. That does count as one of them. So you need to go 4 other points. Sometimes you can go 2 in one direction and 2 in the other direction. So this is going to conclude the first part of 5-6. We'll work on worksheet 5-6A.